Let us continue the gearing. Let us continue the second problem. The gearing of a machine tool is shown in figure. The motor shaft is connected to gear A and rotates at 975 rpm. The gear wheels B, C, D and E are fixed to parallel shafts rotating together. The final gear F is fixed on the output shaft. What is the speed of the gear F? The number of T's on each gear as given below in the table. Now, if I look at the given figure, once again we confirm that it is a compound gear train which is consisting of two set of compound gears in between the first driver and last driven. One is compound gear BC, another one is compound gear DE. Now, if the given things are listed out one by one, the motor shaft is connected to gear A and rotates at 975 rpm. Therefore, the gear A is mounted on gear motor shaft where it is rotating at 975 rpm. Therefore, speed of the motor shaft, that is NA, is equal to 975 rpm. The gear F is mounted on the output shaft. And what is the speed of the gear F? So, what I should calculate in this problem? Speed of gear F, that is NF, is equal to how much? Given that number of T's on gear A, that is TA, is 20, gear B, that is TB, is equal to 50, number of T's on gear C is 25, that is TC, number of T's on gear D, that is TD, is 75, number of T's on gear E, that is TE, is 26, and number of T's on gear F, that is TF, is equal to 65. Like that, speed of the gear A, which is mounted on the motor shaft, that is NA is 975, is given, and I have to calculate speed of the gear F, that is NF, is equal to what? Now, as I said clearly that the given gear train is a compound gear train. Now, to find the speed of the gear F, write down the velocity ratio formula. Here, speed of the first driver to the speed of the last driven, that is equal to product of number of T's on the drivens by product of number of T's on the drivers. In the given compound gear train, first driver is gear A, second driver is the gear C, and the third driver is the gear E. Therefore, A, C and E, three gears are driver gears. In that, A is the first driver. And also, there are three driven gears. Gear B, gear D and gear F. All three are said to be driven gears. In that, F is said to be a lost driven gear. Therefore, if I substitute speed of the first driver, that is NA, by speed of the lost driven, that is NF, is equal to product of number of T's on drivens. How many drivens? 3 driven gears. So, number of T's on gear B, TB into TD into TF, because B, D and E, F. B, D and F are driven gears. So, TB into TD into TF divided by product of number of T's on drivers. Here there are 3 drivers, as I told already, A, C and E. So, TA into TC into TA. If I substitute here, NA is known 975 divided by NF, which is to be found that is equal to TB is 50 into TD is 75 into TF is 65 divided by TA is 20 into TC is 25 into TE is 26. So after substituting everything, only unknown is NF, that is the speed of the gear F, which is equal to 52 RPM. Like that we can solve the second one on compound gear train. Now one more is a third problem, that is, I will read out the statement of the problem. A compound gear train consists of 4 gears as shown in figure. So figure is given. It is a compound gear train. Number of teeth on gears A, B, C and D are 54, 75, 36 and 81 respectively. The gears B and C forms a compound gear. If gear A transmits 9 kilowatt power at 200 RPM and efficiency is 80%, then calculate the torque on the output shaft D. So this is the statement and followed by a figure which is given. Now first point is, here the given gear train is a compound gear train. Consists of 4 gears A, B, C and D. If I look at the figure, I can say it is a compound gear train consisting of one compound gear, that is B and C, because B and C mounted on the same shaft, rotating in same direction with the same speed. Therefore, in between the driver and the driven, there is only one compound gear. Therefore, it is a compound gear train consisting of one compound gear. Now also from the figure I can say there are 2 drivers, gear A and gear C are said to be 2 drivers, and 2 drivens, that is gear B and gear D, so are 2 drivens. So now if I list out the given things, first number of T's on all the 4 gears are given. TA is 54, TB is 75, TC is 36 and TD is 81. And if gear A transmits 9 kilowatt power at 200 RPM, gear A is transmitting how much amount of power? 9 kilowatt power. Therefore, power transmitted by gear A, that is P suffix A, capital P stands for power. Of which gear? Gear A. So PA is equal to 9 kilowatt, that is equal to 9 into kilo means 1000 or 10 power 3 watts. And at 200 RPM, gear A is rotating at what speed? 200 RPM. Therefore, NA is equal to 200 RPM. And efficiency is 30%, means efficiency of the gear train, that is eta, is equal to 80%. In terms of percentage, 80, it means eta is equal to 0.8 to be taken while substituting in the formula. Next, if so, then calculate the torque on the output shaft D. So I have to calculate how much is the torque on the output shaft D, that is capital T suffix D. Capital T stands for torque. Of which shaft? D. So it means here one can understand from the figure, gear A is a input gear and gear D is a output gear. Now, first of all, whatever the efficiency of the gear train is given, that can be written as the ratio of output power by input power, which is equal to output power, means here output gear is gear D. Therefore, that is equal to P suffix D, power transmitted by the gear D, because gear D is a output shaft, and by input power is nothing but the power transmitted by the gear A, because gear A is a input shaft. So hence eta is equal to PD by PA. Here PA is given, that is 9 into 10 power 3, efficiency is 0.8, therefore only unknown is PD, that is power transmitted by the output shaft. that is PD, is equal to, if I cross multiply and simplify, PD is equal to 7.2 into 10 power 3 watts. But whatever the power I calculated of the output shaft D, in general it is equal to 2 pi nt by 60 watts. So 2 pi into N means it is the speed of the output shaft, that is D, ND, into torque T means TD, torque transmitted by the output shaft D. In this formula, two things are unknown. One is speed of the gear D and the torque. So now what I should calculate? I should calculate torque. So TD should be calculated. PD is known, just now we calculated. If I know ND, which is unknown, that is the speed of the gear D, I can calculate the torque. Therefore, now I will calculate the speed of the gear D. How to find the speed of the gear D? As usual, take the velocity ratio formula in case of a compound gear train. So what is the velocity ratio? It is the speed of the first driver to the speed of the last driven, which is equal to the ratio of product of number of T's on the drivens by number of T's on the drivers. So what is the speed of the first driver? That is NA by speed of the last driven is ND. That is equal to number of T's on the driven. There are two drivens, B and D. Therefore, TB into TD divided by number of T's on the drivers. There are two drivers, A and C. Therefore, TA into TC. Now, if I substitute, here NA is given 200, ND, that is the speed of the gear D, which is unknown. Then TB, TD, TA, TC, all are known. If I substitute, only unknown is ND. Then if I cross multiply and simplify, ND will be equal to 64 RPM. Now if I substitute this ND value in equation 1, where that is the torque on the output shaft D, which is to be calculated, is equal to 60 into 7.2 into 10 power 3 divided by 2 pi into ND. ND is equal to, just now we got it, 64. If I substitute and simplify, then the torque TD will be 1074.3 Newton meters. Like that, this completes two more problems on the compound gear train. So, I have solved today. I have summarized once again right from the beginning of the gear train, asking and reviewing and recalling the things which we have discussed in the last class, like what is a gear train, what are the different types of gear train. So now in the 4 types of gear trains, we have discussed in detail in the last and as well as today's class how to find the velocity ratio in case of simple gear train and compound gear train. And also I gave certain tips how to remember to write the velocity ratio in case of simple gear train, having no intermediate gears, having number of intermediate gears. Similarly, how to remember the velocity ratio formula in case of compound gear train. And I solved totally 3 problems. Now, if at all, if any problems on compound or simple gear train is found, I will try to give them as an exercise. So, you please try to solve it as and when I upload the problems on simple gear train and compound gear train. Now, this completes totally introduction and the 2 types of gear trains, simple gear train and compound gear train, with 3 problems. In the next class, I am going to start a third and fourth type of gear train, that is reverted gear train and epicyclic gear train. So thank you one and all. Have a good day.